Okay, so we're gonna go into completing the square, and really what that is there's two forms you've learned about a bit. There's technically a third form, but we're focusing on these two. This is your standard form of a quadratic, okay, and this is your vertex form. The reason they call that vertex form is it's easy to see the vertex. Here, the vertex is essentially your h and your k, so you know it's your h and your k value of the vertex. And standard form is because there's a lot of times this is how a quadratic's represented. Now, these forms can represent the exact same equation. What we're going to do, completing the square, is taking standard and going to vertex form. Okay, and that process is known as completing the square. I'm just going to draw a square, okay? So completing the square is how we go from standard to vertex form. So here, in our question, number 1, I have a quadratic in standard form. Okay, so this is a process you kind of have to partially memorize. Okay, so the very first thing we want to do is we figure out what the a value is. And the a value in this case is the number 2. You're going to take that a value and you divide just the first 2 terms by your a value, like a common factor. So the 2 will come to the outside. Okay, you'll have x squared minus 6x. And the positive 23 stays on the outside. Okay. Now our goal here is to make a perfect square trinomial, which is something that factors so that both the brackets are the same. Okay, we won't go too much into that.
Is that going to become negative 6x plus 6x?
Not quite. What we're going to do is we're going to take this value, and there's a little formula we need to remember, which is b. I call it b because this is our new b. In standard form, this is usually known as b, but we've changed it a little. Divided by 2 squared. Okay? So we take the new b value, which is negative 6. So negative 6 divided by 2 is going to be negative 3. Negative 3 squared is 9. What we're going to do is we're going to add and subtract that value within this bracket. So our next line will read 2x squared minus 6x plus 9 subtract 9. Okay, and the reason we add and subtract 9 is because it's kind of like doing nothing. Because if we were to combine them, it'd be a 0 and we'd have the exact same thing. But the reason we're doing this, like I said before, is we're creating a perfect square. Now, I need to get rid of the negative 9. We only really need the positive 9 in this bracket. So I need to... Exactly. And when we do that, we have to multiply by that first value there. Okay? This is looking familiar? Mm-hmm. Yeah? Okay. So we have 2. Then we'll have x squared minus 6x plus 9 will still be in the bracket. Now negative 9 times 2 will give us negative 18 plus 23. Okay. We'll quickly evaluate what's on the outside there, okay? So we have 2x squared minus 6x plus 9. That's going to be positive 5, okay? So now all that's left is factoring this bracket. Now, we could go into the long process of factoring, but since we created this trinomial, remember we started up here and we did this process to get these values and took a 9 out to get this purposely. Because we know what we've made is a perfect square trinomial. You want to maybe just look it up again later, but a perfect square trinomial is when you factor it, you're going to get 2 brackets that are identical and they can just be represented as one bracket squared. Okay? So since I know that, and I know it's a perfect square trinomial, I can use a shortcut to factor this. I'm just going to square root the first and last terms. So the square root of x squared will be x, and the square root of 9 will be 3. So in my one bracket that we know is going to be represented squared, right, we have the plus 5, I'm going to have x and 3. Now I don't know if it's a plus or minus yet. Oh, and the way I figure that out is by looking at the middle term. If this is a negative, it becomes negative. If it was positive, it would have been positive. So our vertex form is 2x minus 3 squared plus 5. So we've just turned our standard into our vertex form. Okay? Sorry for time here. 4 minutes, great. On top of that, I'm going to show you something. Just to make sure we've done this right, I can go back. I can turn vertex into standard form by expanding. Now this is something you've done before, so I'm going to show you this a little quicker. Okay. So I want to make sure I didn't make a mistake in this. So I'm going to take our vertex form, and I'll do this in blue. 2x minus 3 squared plus 5. Well, that squared just means that bracket times that bracket, right? So we have 2x minus 3 times x minus 3 plus 5. Okay? I'm going to FOIL these brackets. Now I'm going to do the foiling very quickly, especially because they're identical. I know that this is going to be x squared. Negative 3x minus 3x will give us negative 6x, and negative 3 will give us positive 9. And if you notice, that's very similar to what we had up there, right? In fact, it's identical. Great. Next, I distribute the 2 to everything. 2x squared minus 12x plus 18. Do you remember that 18 from before? Plus 5. And all I got to do is collect my like terms at the end. 2x squared plus 23. And is that exactly what we had as a standard form?
Yeah.
I think it was. Let's zoom out and take a look. 2 minus 12x plus 23. Exactly. Okay, so we've done the process yet. So I wanted you to focus on going from standard to vertex, but you can quickly expand to double check your answer.